Hey 7th graders, today's lesson is 2.2 Traits in Reproduction. Okay, we're going to start focusing on a little bit more about mutations in this lesson. So your learning targets for today. I can model how a gene gives the instructions to make a protein. We learned all about the structure and function of proteins in chapter 1. So we're going to be able to kind of incorporate how we make that protein and then how if we mutate that protein it would change the structure and therefore the function of a protein. In your second one, I can describe how a mutation changes a gene and therefore the protein it makes. Okay, so moving on, you guys had a little bell ringer today on slide 2. If there is a mutation in a gene of DNA, what are some things you might see happen to the protein molecule that the gene makes? So we know that DNA is the blueprint for life. But really, it's the instructions to make proteins. So if we mess up the instructions, what are some things that you guys might see happen to the protein? What are some changes that you guys could see? Try to think of at least 2 things that could happen to that protein. Again, remember that the structure of the protein is really important to the job it performs. It's kind of like a key in a keyhole. So if we mess up the key, what are some ways we can mess up that key and how would that affect its job? It does. Okay, so if you guys need to take a second, pause and complete activity 1, and then we will move on. All right, so in activity 2, we're going to do a little hands-on activity, but of course, you at home, unless you guys own your own K'NEX, might have a little bit more of a difficult time with this. So what you guys would have if you were in class is an envelope. Let me read the instructions to you first. So modeling how proteins are made in cells. Do genes build proteins, or are genes only the instructions for building proteins? You will work in a group to model the role genes play in building proteins. The envelope represents the nucleus. So in the bag that everyone in class got, they got this little envelope that says the nucleus. Okay. The envelope represents the nucleus. Each instruction inside the envelope represents one copy of a gene. So if I were to open this envelope up, you guys would see that there's 2 instructions here, okay? One comes from mom, one comes from dad. So we kind of have 2 for that reason, okay? 2 students will serve as readers. The other pair will serve as ribosomes. So one person's going to read the instruction. The other person's going to build the protein, okay? That was mom's side. Now we're going to do dad's side. One person reads the instructions. One person builds the protein. Okay, in class we did a little bit different where we just built them together as partners. Okay, the pair of readers should take one of the instructions from the envelope and read it out loud to one student ribosome. The ribosome that receives the instructions should build the protein molecules accordingly. So the ribosome is the one that's kind of responsible for gathering all the little ingredients, which I'll show you here in a second, and putting them together to form a protein. After completing this activity, discuss and answer the reflection questions below. Okay, so first things first, let's take a look at the ingredients, if you will. So these are the things that are available in the little bag. You guys can see a picture of them. Obviously, I'm holding you guys up some in front of the camera right now. They're just little K'NEX. If you guys have some K'NEX at home, you're more than welcome to do this rather than just kind of theorize what it should look like. Okay, so in there we got some red rods. Okay, so these are what the red rods look like. Okay, and we've got some yellow rods. Here's what those look like. Okay, and then we've got some blue as well. We've got these little orange connectors. We've got gray connectors. And we've got a couple of these red connectors. Okay, whenever we're snapping the rods and the connectors together, we're going to snap them together so it's kind of flat. So if you guys look at the screen I'm showing you, you guys can see how they're flat right there. You guys can also see this little picture right here to show how we snap them together. So you guys can kind of get a visual. It's very 1 or 2-dimensional, okay? All right, so rods and connectors connect like this, okay? Here are your guys' instructions. So those of you guys working from home, you guys obviously don't have the K'NEX. You guys don't have the envelope. You guys don't have the instructions sitting in front of you. So that's just something that the kids in class have, but realistically, they're not going to use them either. Okay, so what we would have is one partner in class is going to read the instructions, the other partner is going to build it. So I'm going to kind of show you how one might look right now for A1. Okay, so step 1, lock the end of a red rod, here's my red rod, to a red connector. Okay, and step 2, lock the end of a second red rod to the same red connector, making a wide V shape. Okay, so there's my wide V shape right there. Okay. Step 3 says lock a second red connector to the end of one of the red rods. So I'm going to go ahead and lock this on there. Okay. And then finally, step 4, lock the end of a third red rod to the second red connector so it makes a wide zigzag shape. So here's my zigzag just like this, okay? A little zigzag for you, almost looks like a slightly incomplete W. Okay, then what I would do is I would go down here and say, all right, we have 2 copies of the A1 protein, so this would be our genotype, okay? And I'm going to draw a picture of what my A1 protein looks like. So it's got one long red connector, another, and then a third, and then I can kind of draw like maybe a little triangle or something here to show where my little connectors were, okay? In this case, our genotype is A1A1, so mom passes down the gene to make this protein. Dad's also going to pass down the gene to make this protein. So this is the point in class where the readers would switch. One would become the ribosome, one would become the reader. But because we're looking at the same gene or the same copy of a gene but from different parents, and they make the same protein, we're going to build 2 A1s. So I would draw 2 of these. They're going to look identical. Okay? So this individual has A1A1. Okay? The next individual will be a little bit different. They have A1, which we already know what it looks like, so you can go ahead, take a second, use your draw tool to draw that in there. And then they have A2, so then you guys would need to go up here, you would read the instructions, and you guys would kind of mentally build this. Like I said, if you have K'NEX on your own at home, great. You guys can do it at home, or you guys can just think about what it looked like. You guys can notice that the yellow is a little bit shorter than the red. So you guys can see that in the picture of your supplies on slide 5, or you guys can see what I'm showing you right here in the video. So it's about maybe 2/3 of the size, okay? So your yellow would be slightly different. That would be what you guys would be using to make A2. So go ahead, take a second. I want you guys to read through the instructions for A2, and then you guys would draw a heterozygous genotype where we have an A1 and an A2 passed down. Mom passes down one, dad passes down the other. Okay, finally, then you're going to build 2 A2 proteins and draw them on slide 10. So go ahead, take a second, finish up the drawing through slide 10, and then you guys can hit play again when you're ready. All right, some questions to wrap up our first little hands-on experiment. Okay, in this modeling activity, what do each of the following represent? The envelope, the instructions, or the student building the molecule? So if you guys need a refresher on that, go back up to slide 4 and read through your instructions. It'll kind of remind you guys what each of these parts of the simulation did for you. Okay? Finally, which claim about genes, roles, and building proteins best fit considering the modeling activity you just completed? So you got 2 claims here, claim 1 or claim 2. You guys are going to circle the one that you guys find to be most accurate. So claim 1 says that genes provide instructions and build proteins. So the genes not only give the instructions, but they're also responsible for building the proteins, okay? Think about what you guys did in the lab and what that looked like. Second one, claim 2, genes provide instructions for making the proteins, but they do not build the proteins themselves. Okay, so think about, again, the roles that you guys saw that I described to you guys in that. And again, think about slide number 4 that has your instructions for the activity as well, and see what you guys can kind of reason out of there. So circle either claim 1 or claim 2. Okay, when you guys are done with that, go ahead, take a second, answer your questions on slides 11 and 12. Pause the video and then come back when you're ready. All right, moving on to slide 13. This is activity 3, mutations hands-on. It's very similar to what you guys did in 1, except we're taking those 2 copies for the A1 and the A2 protein, and we're going to see different mutations without them. So we're just going to kind of build the protein and see what happens if we were to have certain mutations. So we're going to kind of ruin the steps, if you will. There was 4 steps. We're going to kind of tweak one of those steps, and then we're going to see what happens to the protein when we have that mutation occur. So directions, mutations are occurring everywhere. You will need to remake your 2 proteins following new mutated instructions. So there's 5 total mutations that we're going to look at. They're going to be different each time. We're going to reset each time. Okay, reread your new instructions and draw your 2 new proteins on the correct slides. Okay, so you guys can kind of just ignore this. I'm going to delete this right now. Okay, you guys will see where to draw, and I'll show you that. Okay, so first mutation, mutation number 1. So we have A1, and we can see that normally our A1 protein looks like this. So red long connects, the little red connector, another red connects, red connector, and then the third red connects. Okay, we're going to have a mutation occurs, and we're going to see how that protein is different from this first one. So I'm going to kind of do this first one with you guys. Okay, in this mutation, we're going to substitute the original step 1 with this step 1. This is the mutated step. So step 1 now says lock the end of a blue rod to a red connector. So I would grab a blue rod, I would grab my red connector, okay? And then I would carry on like normal. Okay, lock the end of a second red rod to the same red connector. So I grab a red rod there. Okay, and step 3, lock a second red connector. Okay, and step 4, lock the end of a third red rod, which I would do right here. So this would be my final protein. There we go. I'll pull that back so you guys can see it. So then I would come in here and I would draw it and say, all right, it's a little backwards for you guys, but here's a little teeny tiny blue one. And then we've got, is that even blue? Here we go. There's a blue one. So there's my little blue one, and then the rest are all going to be red. So here's my red connector, my red rod, and my red rod. And here's my other red connector. So we can compare. Obviously, this is very neatly done, and this isn't so much. But you guys can compare. We've built a protein, but the protein's different. So that's the last thing you guys would do on here is say, all right, the change in the instructions caused the protein to, you guys would either say be incomplete, no longer exist, have a different structure, or have the same structure. In this case, we built a protein, but it's slightly different because of this little guy right here. It's not the exact same as the original one was. Okay, so you guys got a couple more mutations to do. So go ahead, look at this one. We're building A1 protein, so here's your normal. Okay, follow your new step 3. So do step 1, step 2, do the new step 3, and then step 4. And then think about what happens. One thing you guys gotta know is, like, if your step 4 says lock the end of a third red rod to the second red connector, making a wide zigzag shape, if you don't have a red connector there, you guys can't proceed. Okay, so you won't have anything to do, so you guys wouldn't have a full protein. Okay, you'd have something, but it would definitely be different, but it would be also incomplete. So think about that as well as you move through these. This one, you guys are making A2, so here's your normal A2 protein. So you guys are replacing step 4. This one, you guys are doing skipping steps 1 and 2 and going right to 3. So think about how that would look if you guys were trying to build that. Okay, and what the effect would be. And then finally, lock a light gray connector to the end of the second rod. So you guys are substituting step 3. Okay, so go ahead, take a second to complete through slide 18, and then we'll move on. All right, so you guys should have just finished up looking at different mutations you guys might see. Hopefully you guys completed through slide 18. Finally, you guys will kind of do your little exit ticket for class today. Those in class are going to give me one way a protein might be affected from a mutation on the way out the door. So you guys are going to list all 4 just as well as them. So from this activity, list at least 4 effects you might see in a protein if the DNA to build that protein has been mutated. So what are some things you guys might see you need a list for? In your bell ringer, you guys tried to brainstorm 2. Now you guys should know 4 different changes, so list them there. As usual, do your wrap up. Do you have any questions, yes or no? If you have questions, type them right there. And 4, 3, 2, 1, how do you think you did on this assignment? Go ahead and hand it in, and I hope you guys are having a great day. Bye.